Okay, so good afternoon everyone. So last class I discussed about different classifications of instruments. Okay, so another few portions are pending. Then we can conclude this introduction means module one by today. Okay, so I think I hope all of you are able to understand that what is the different classifications. So some tabular form of classifications also mentioned over here. You can see that one that classification of the measurement in based on their applications. Okay, like from where you are going to be means implications. Okay, you are going to be implemented, okay, for measuring purpose. So normally that measuring instruments are there, it will be broadly classified that absolute instruments, then secondary instruments, again secondary instruments having three important applications. Okay, so like indicating instruments, implementations, implications, like indicating instruments, integrating instruments. Indicating means the deflections, only the pointer having deflecting as per that current or voltage or whatever quantity we are going to be measured, that is passing through that meter. Okay, so that pointer of the meter will be deflecting. Okay, so that is your secondary instruments. Indicating, then integrating, okay, like energy meter type things. So integrated with the time, then recording, then after certain time means with the duration of that entire process, measuring process, it will be recorded those value. Okay, so that is your measuring instruments. For absolute instruments that I have told, that is absolutely correct. Okay, means those are absolute, that you can only manufacture, or you can use that instrument as a reference of your normal manufacturing unit. Okay, another things are there, analog instruments. Okay, it's your analog instrument, then digital instrument, and broadly classified analog instrument that I have been discussed. Okay, the applications. Okay, and digital instruments. Okay, the mechanical instrument, electrical instruments. Okay, electrical instruments also having some specimens bunching, that electronic instruments and the electrical instruments. Okay, that is more sophisticated electronic instruments. Okay, and manual instrument, automatic instrument, finally self operated instrument like power operated instrument. Okay, finally deflection instrument and null output instrument. So these all are the important points, okay, of the different in measuring instruments, classifications of the different instruments. So next one is that electromechanical instrument, electromechanical measurement system. Okay, normally electromechanical instruments measuring process are normally used in our application, like that I already discussed, that speed control of a machine, of a motor. Okay, so how we are going to measure them, that is given here. Okay, like that's why it is mentioned that electromechanical measurement system. Okay, first you have some mechanical device. Okay, mechanical device means it may be the shaft of the rotor. Okay, rotor shaft of your machine. In generalized form, you can say like the machine, but specifically you know that is your motor. Okay, the mechanical sorry, the shaft is there. So if motor is working, so shaft will be rotating in nature. So you have to fetch the data from that rotor. Means how fast you need to know the values. Okay, you need to know the RPM value. So how would you get it? From transducer. Okay, so transducers are there, so directly that mechanical value is converted to the electrical signal. Okay, that means you are getting some voltage. Okay, then exciter is there, auxiliary power supply for that voltage. Why that is required for transducer? Sometimes whatever the transducer need to be working conditions. Okay, like it's a taco generator. So taco generator inherently it's an machine like DC machine. So RPM means there is a changes, there is a options for cutting of flux. Due to cutting of flux, that equivalent EMF will be developed. Okay, so cutting of flux means definitely some magnetic field is required. Basically that motor shaft is rotating. How would you work taco generator? Okay, so taco generator having one very sap type of thing, normally analog taco generator as well as digital taco generator. Okay, analog taco generator, what you will do, you just give a laser beam. Okay, there is a in Motosat one detector is there. Okay, not detector, means sensor type of white color sensor is there. Okay, it's like a paper type of sensor, so that is attached to the sellotape. Okay, then what you need to do, you have to give him that laser beam from the tachometer. So how much time means that white color band is passing through that laser beam, that will be calculated by the tachogenerator. That is digital tachogenerator. But in case of analog tachogenerator, what you will do? You having the tachogenerator having inherently shaft. Okay, one shaft is there that can be rotated. So what you will do? You just touch the shaft tip to the motor shaft tip. Okay, then both of the shaft tip that touch together. Then if motor is rotating, motor shaft is rotating, so automatically tachogenerator shaft is rotating. So that's an DC. It behaves like a DC generator. Okay, generator means it can convert mechanical energy to electrical energy. Okay, so what happened then? Tachogenerator having its own shaft. That shaft is connected with that arms of the tachogenerator that directly touching with your motor. Okay, that you are getting the speed of that motor shaft. Okay, directly touching with this. So if the motor shaft is rotating, so tachogenerator shaft also rotating, and external power source is required for getting for giving a permanent magnet field. Okay, some electromagnets are there inside of the tachogenerator. So that magnet is there, now tachogenerator shaft is rotating. Through what? In that magnetic field. Okay, how fast it is rotating means cutting of flux that may cause some EMF. Okay, so on data sheet is there with the tachogenerator that what how much RPM shows here how much equivalent EMF. Okay, so that will be tested by that manufacturing company, but directly will get it from that market with the data sheet, and you have to calculate how much EMF is that. Okay, then if you want to make it in closed loop control, then what happen? You have to sense that EMF, then you have to process that induced EMF or that voltage, tachogenerator output voltage for that for to feed to the controller. Okay, so that's why that amplifier circuits are needed. Okay, that amplifier circuit will be the last class I told you no condition signal. Okay, signal condition. Okay, so normally that EMF values are less. Okay, if you amplify that voltage level, then what happen? You can it should be in the measurable range. Okay, so you can go up to that level of measurement. Okay, then you can compare it and you will get that error signal. That error signal passing through that controller, and after the control provides some control signal. Okay, that will provide design for that that will gives a response to the system, means to the actuator. Okay, that's the way. Okay, then it is written the data presentation. Okay, whatever data is there, it will be showing to the together or directly it will control the system. So I think all of you will understand why it is called electromechanical measurement system. So it is related to electrical as well as mechanical system. Okay, both the system is associated together. That's why it is called electromechanical measurement system. So transducer is a sensor that can convert any of the physical phenomena to the electrical phenomena. Okay, obviously that transducer contains that crystal whatever things are there, that may be individual application, individual things, properties of the transducer elements are needed. Okay, I think all of you are able to understand what is the basic classifications of the measuring instrument as well as how that electromechanical measurement systems are working together. Now we need to know about the advantages of three most important things. Okay, so advantages of mechanical instrument, then disadvantages of mechanical instruments, why we are switching to that means convert to everything in the electrical point of view, then advantages of electrical and electronic instruments. Okay, these three things are very important. Okay, so first one is that what are the most important advantages of mechanical instrument? Definitely it is cheaper in cost. Okay, compared to electrical system. So costing will be different. Okay, in electrical system is more sophisticated than your mechanical system. Okay, that's why more costly is it is. If you go for electronic system, so definitely it is more costly than your electrical system. system. Okay, so it's cost dependent. So mechanical system is cost effective. Okay, so that is number one. Number two is that more durability due to rud construction. Okay, the rudged construction. Okay, so definitely the durability of that instrument is more. Okay, so more sophisticated instrument means it having some other limitations. Okay, like other limitation means cost will be more. Okay, as well as that application means possibilities. Okay, so some the applications, it can work in adverse conditions, but mechanical electrical or electronic measuring instruments may not be work that much of adverse situation. Okay, so these two another advantage. Then simple in design and easy to use. Definitely easy to use, that's why it is cost efficient. No external power supply required to for that operations. Okay, reliable and accurate for measurement of stable and time invariant quantity. So it gives you that stable value and time invariant value. Stable and time invariant value means whatever reading you are taking throughout the period, it will gives you the exact thing. Okay, so means it will not means all the time you will get that amount of value. Okay, but what are the most important disadvantage? First one is the poor frequency response to transient and dynamic measurement. So large force required to overcome the mechanical friction. So initially what happened, you have to, if you connect the your instrument to the system, so mechanical system means definitely time constant is more than electrical system. You know that is L by R and whatever J by B. Okay, so both of the time constant of your system. Okay, so definitely electrical system having very less time constant. That's why rise time also very less. Rise time is less means system performance or system dynamic is more fast than your other system. Mechanical system having in bigger means that rise time will be more. Okay, why it is more? Time constant is more. J by B means inertia by that, you can say. So that value is more. That's why the time constant is more. So response time is very slow. Okay, that is another options. And due to that slow response, you will get that poor frequency response. Okay, for the transient behavior, transient and dynamic both are almost same thing. Okay, then incompatible when remote indications and control needed. So that why it is incompatible? Basically, there is no sensing unit, other kinds of things is not directly related to the mechanical job. Okay, mechanical job means you are directly giving some signal and outcome is coming some mechanical out. But for sophisticated control, everything will be done through the electrical signal. Okay, so if the electrical signal is not using with your system, so that efficiency of the system will be very less. Okay, compare, that's why electrical measurement is more convenient and more popular than other process. Okay, then the cause of noise pollution. Okay, so it may cause for basically some corrosive sound will be there, some humming sound, the vibration sound, lot of things will be there. Okay, mechanical system, lot of sound pollutions are there. So that's why it may cause for unnecessary noise pollution. Okay. Now, what are the most important advantages of electrical and electronic instruments? Okay, that first one is the non-contact measurements. Okay, so no need to do the direct contact with your instrument. Non-contact measurement. This instrument consume less power. Okay, electronics electrical instrument directly. Sometimes semiconductor devices are connected or associated with the system. That's why less power it will be taken by the system.
So what
Okay,
is mean by non-contact, sir?
huh?
Non-contact, sir. Can you explain? Like we have to make connections.
Non-contact means non-contact measurements means sometime that I am telling you, no, tachogenerator example. Okay, there is some flux lines are there and that shaft is inside means rotating inside of the flux. So cutting of the flux. So there is no direct contact of your primary means motor shaft to the instrument shaft. That is another issue, number one issue. Second issue is that sometimes we are using in energy meter, we are using some braking magnet. Okay, means the disc is moving. Okay, so where some magnetic field we are using. Okay, so that can control the speed of that disc. Okay, so that is called that non-contact measurement. Then indirectly, there is no direct contact between your system and your applications. Means whatever measurements are there, you can see that directly passing through the meter, and you can see the pointer. Okay, so there is no contact between two systems, direct contact between two systems. If there is a contact between two systems, definitely there is some mechanical noise like corrosion, like torsion. Okay, like some noise, means metallic noise will be there. That is not related to for electrical and electronic instrument. That's why it is called non-contact measurement. Okay, this instrument will consume less power. Definitely, there is no contact between two things, so definitely less power. Okay, only the consumed by that meter, that power it will be measured, means taken by the system, and unnecessary power loss is not there. So that's why cost efficient. That's why it is not like cost efficient. That way energy efficient. So definitely it is more costlier than the mechanical energy. So it's not the cost efficient compared to the mechanical instrument. But in point of view loss, it is more efficient. That's why we have to pick those type of electrical and electronic instruments. Okay. The compact in size and more reliable of in operations. Definitely size will be very less. Okay. Greater flexibility. Okay, good frequency and transient response, that I am telling in the previous case. So low frequency and transient response was there, frequency to transient and dynamic response. But here it is good, basically time constant is less, that's why response time also very fast. You will get the very good results within very short duration of the time. Remote indication and recording possible, so you can control your instruments from remote location also. That is called ICT enable thing. Like you are working in a switch gear. Okay, switch gear, you try to operate the switch gear from that control room of a substation. So it is not possible to go there and also means manual turn on turn off. It is not possible, that it's a huge voltage there. In the mode of 220 kilovolt or sometimes it is 760 kilovolt, huge voltage. Okay, you cannot operate manually, so you have to go for autonomous system. Okay, so you have to follow with that structure, or you have to follow with their procedures. Okay, for getting for working on it. Okay, the remote indication recording possible. That's I'm telling, that remote you can control the instruments from remote control now. Or if you know about that Internet of Things, means IoT based controlling approach through application, means through app. Okay, so everything is related to each other in smart grid concept. Okay, the application procedure greater than that procedure in mechanical instruments. Okay, so definitely application process is greater than, basically there are a lot of intermediate steps. Basically the devices are more sophisticated, so it's a very costly device, and you have to handle that costly device with carefully. Okay, otherwise it may be damaged. Okay, that's why that's why you have to maintain some other precautions, and you can also control from remote location also. Okay, through the global server or local server. Okay, whatever server you can use it. Okay, and use it means local server, your locality purpose. Global server means you can control your switching gear from your home place to it may be 100 kilometer away from your home. Okay, that is also possible. Okay, and the amplifications process, amplification produce greater than that produced in the mechanical instruments. Okay, so amplifications are needed. Okay, how much value you have calculated, then you have to amplify it for comparing that value. Okay, that is one another important thing. Now, what are the most important definitions for static characteristics? Okay, so we are using that instrument, so we need to know the different important terminologies. Okay, so different important terminologies we need to know. So, what are the important terminology? First one is that accuracy. Second one is precision. Then resolution, speed of response. Okay, accuracy means how accurately you can design or you can manufacture in your device. Okay, so if it is not accurate, okay, so if it is not accurate, so all the time it will not gives you the same reading. So there is some, the reading is in erroneous in mode. So that's why it is called, the accuracy is the closeness which with which the instrument reading approaches the true value of the variable under the measurement. So if you have some standard, yeah, instruments, first you need to cross check it with the standard reading meter. Okay, so you have some parameter, you can already know the exact values of those parameter. Okay, basically it's a support kit. Okay, sometimes what happen, sometimes what happen, support kit means the manufacturing companies are providing this kit as a reference. Okay, so you have to check it, cross check it. Like in your oscilloscope, we are having some where the options for connecting one of the probe to calibrate that value. Okay, there is a source of some
Excuse me,
square wave having some frequency. You can connect your probe to that terminal directly. You can understand what is your actual value of that oscilloscope. Okay, so if it is not coming properly, so there is a chances to cross check it. Okay, so that's why based on the accuracy. Okay, so all the time it should come the same response. Okay, that how much accurate your device, that is very important, you have to find out. Okay, that's why it is called the true value. How exactly true value is given by the instruments from the of the variable under the measurements. Accuracy is determined as the maximum, accuracy is determined as the maximum amount by which the result differ from the true value. So how much difference is there with your true value, that you have to find out. Okay, 100% accuracy is needed, but it is not possible exact 100% accuracy. Some of the portions of the accuracy is means reduced. Okay, so some of the values not coming properly, so you say like that the accuracy is now reducing. Okay. Next one is intensity accuracy. Intensity accuracy of the instrument itself, accuracy by the observer, variation of the signal to be measured, and whether or not the quantity is being truly impressed upon the instrument. So these four points are important when you are measuring, when you are designing for measuring instruments. Now the precision. Precision means reproducibility. Means if your precision is well, then all the time you will get the same reading. Okay, so regular interval if you test it, so you will get the same reading. That's why is a precision. Okay. Next one is the resolution. Okay, resolution telling that if the input is slowly increased from some arbit value, it will be noticed that the outcome or output does not change at all until the increment exceeds a certain value called the resolution or the discriminations of the instrument. So initially it is not moving due to its initial internal inertia. After getting some value, automatically it can run or it can work. Okay, so that's why it is called that precisions. Okay, so how successive difference is one another means repeatedly you are taking the value and you have to find out the precision. Resolution means sometimes what happen, 1/4 of your actual reading you are able to measure, sometimes 1/5 of your actual reading, means the resolution is more. Okay, like the if the input is slowly increased from some arbitrary value, it will be noticed that the output does not change the until the increment and in exceeded a certain value called the resolution or discrimination of the instruments. Like your previous case, what happened? Not exactly previous case. You are giving some input, but output has not been changed. Okay, and other parameters are not been changed. After gradually increasing up to certain value, automatically it will work. Okay, that is your resolution, and that resolution also sometimes known as that sensitivity. Okay, speed of response is how
Excuse me, sir.
fast or how quick it is reach its steady state value. Okay, so on motor maybe rotating, you are giving some reference speed. Okay, directly it reach that reference speed. So you say
Excuse me, sir.
like the speed of system is very fast, but normally if it is not reached that value, so you can say like this, speed is good. Huh? What happened?
Excuse me, sir. Sir,
Huh?
actually, from a long time, the slides got stuck on that advantages of slides, sir.
That I don't know, but here it is moving. Now what numerical problem is there? Is it visible from your end? Two examples are there. Is it visible from your end?
No,
No,
sir.
sir. It was not visible.
No, sir. No, sir. It happened only your class.
Is my slide is visible from your end?
Yes, sir. Now the definition of some static characteristics are visible, sir. That's right.
Definition.
Yes, sir. Accuracy, precision, resolution, and speed of response. Those
No,
things are.
actually I'm selecting some. Acha, that is fine. Okay. Now you can see one example is there.
No, sir.
Measurement of error.
Sir, only the definition page is visible.
The definition I have completed. Now after that it is coming. Examples are showing now.
No, sir.
Sir, actually, when you are explaining the definition page, the page was not visible, sir.
Is my slide is visible now? Example 1. Example
No,
1.
No, sir.
Still have
I think
accuracy.
you had selected some other.
Sir, you can share the slide.
Is my slide is visible from your end?
Yes, sir.
Yes,
Now
sir.
visible.
Now example
Yes,
1 and
sir.
2 are visible.
Okay, so there are two examples. Okay, based on the resolutions. Okay, based on the resolution, and how to find out the resolution means minimal number of means range you need to find out. So first example is still like that uniform scale 50 divisions. Okay, full scale reading is 5 ampere. So 50 divisions are there for 5 ampere. For 1 ampere, if you go for that milliampere range, so for 1 ampere how much divisions are needed? So 5 ampere by 50, 5 by 50 in ampere range. Okay, if you go for the milliampere range, so you have to multiply the 1000. So 100 milliampere for single range. Now it is telling that it can read up to 1 by 4. It can up to read 1 by 4 scale divisions. Okay, the resolution is 1/4 of your actual scale division. So actual scale is 100 milliampere. So you are multiplying that 100 milliampere with 1 by Fourth is, so it is coming 25 milliampere. So 25 milliampere is your resolutions of the instruments. Okay. Another example is also be there at 0 to 25 ampere ammeter has the guarantee accuracy of 1% full scale reading. Okay, accuracy is 1% full scale reading. Okay, current measurement by the instrument is 10 ampere. Determine the limiting error of the percentage. So limiting error formula is there from the equations, mean directly it is taken from the equation. Okay, so that is delta A. Delta A means ER into A. ER means it is given that how much percentage is accuracy is there. So 1%. It is stated that 1% into 25. 25 it is reading that maximum 25 ampere current reading is there. That's why multiplication of 25. So it is coming 0.25 ampere. Magnitude of the current being measured, it is saying that 10 ampere maximum. Okay, so relative error is how much? Delta A by delta. Okay, delta A it's already given. Sorry, you have already calculated, that is 0.25, and A absolute values are already given, that is your 10 ampere. Okay, so direct ampere reading, so it is coming 0.025. Now current being measured in between the limit also be there. So actual A means actual plus minus 1 plus minus epsilon r. So you can put those value, epsilon r value we are directly getting from here. So that values are coming. So limiting error is 2.5%. Okay. So simple thing. So if you need to go through the error, okay, so you can easily understand what are the basic errors. So first there are different types of error. First one is a absolute error. Okay, what is absolute error? Then you can see that relative error. Relative error means it is coming in how much changes are there with the reference. So that is a relative error, epsilon r. So in my previous problem I told you, when I just take an example. So if you go through that slide, so you can easily understand what are the normal measurements of the errors. Okay, so what are the value? The exact value need to be measured. Okay, that is our main agenda. But all the time what happens, we are not able to get the exact value. Some of the minimal, if your accuracy is very good, so some portion of that minimal changes are also be there. Okay, the minimal differences also be there. Okay, so this is always some difference between the measured value and the absolute or the true value of the unknown quantity or the measured quantity. So whatever values we are going to be measured, that is the measured quantity, unknown quantity. Okay, now making the difference with your reference value, that is your absolute error. Okay, so now we want to how much changes is there with your reference value. Then you need to find out you need to calculate the percentage. So that is coming relative error. Relative of what? Relative of reference value. In single word you say like that, relative of true value. What is your actual value and what is your absolute error value? Means how do you calculate those things. Okay, then the difference is there. It is called relative error. Okay. The another thing is there, absolute error epsilon 0. It is delta A is negligible when the difference between the true value A and the measured value am, their differences are need to be known. For the unknown quantity is very small or negligible, then the relative error may be excess, like that. So after that you try to find out the relative error. So to whom that the relative error you need to find out in the form of measured value of actual value. Okay, then relative error also can be calculated in percentage form. So percentage error is that relative error into 100. So simple thing. So directly it is coming E0 by AM, from formula it is coming E0 by AM into 100. Okay. What are the range of the value? So delta M plus minus delta A is there. Okay, so based on that range you can select. Okay, that values will be selected. The limits of these deviations from specific value are determined as limiting or the guarantee error. Okay, so you are going to find out that value. Okay, the magnitude is given quantity having a specific magnitude m, and the maximum or the limiting error is delta m. Okay, must have the magnitude between the limits. So how much deviation is there, that is important. So in percentage form. If it is more deviate that value, actual value, so you should not use. Basically, that is that type of things are less costly. Okay, but more costly means you have to go for sophisticated one. Okay, for example, the measuring value of resistance is 100 ohm. The limiting error is plus minus 5%. Then the true value is coming 100 plus minus 5%. 100 plus minus 5. So it is coming 100.5, or another option is there, it is 99.5. It is subtracted from it. Okay, types of error. So then the types of error also very important. Basically, we are going to measure everything. So what are the very common types of error that you know? That type of errors are there. So what are the different errors are there? Number one is gross error. Okay, in from you say like the gross error, then systematic errors are there. Okay, so gross error, systematic error, then random errors are there. These three are the normal. Error options. Okay, so then the gross error means, what do you mean by the gross error? Gross error occurs because of the mistakes of the observed readings. Okay, so mistake observed reading means what happened, or instruments are recording. So there is some calculations. Okay, so calculation between the processing. Okay, so in the processing that values are there and the calculations are there. So then you are subtracting them directly, you will get some of the DC value. So that is called the gross error. Okay, then systematic error means, so how is it coming? Due to aging effects of that instruments, or due to environmental situations, or that instrumentation error. So inherent properties, that systematic errors are the different inherent properties. So how it will be written like that? These are the error that remain constant or change according to a definite laws or repeated measurements of the given quantity. So whatever quantities are there, okay, based on the quantity, sometimes that instruments having inherent some problem, due to that inherent problem you are getting such type of error. So it is called instrumental problem due to aging effect. Environmental problem means at that that place is very dusty. Okay, then what happened? Due to dust, your so the repetitively if you taking the reading, then due to dust, what happened? That the precision of the device has lost. Okay, so dust is there, so definitely the accuracy of the instrument will be lost. Okay, so after some times that may cause for unwanted aging of the system. Then random error also mean variable magnitude or sign, it do not maintain sometimes known law, that is called random error. Random error means sometimes you are changing the unintentionally changing the polarity of the system. Okay, it's a DC, so definitely if DC meter is there, so you are not able to get the reading, so you will get the negative reading. Okay, so negative reading means the pointer is just below of your zero. Okay, so you are not getting it, but random, that is called random error. So again you need to reconnect it by changing the connections. Okay, so it's a random error. Okay, here you can see different types of error. Okay, so normally that pointer should touch that zero value. Okay, so if it is not touched to the zero value, so you can say like that there is a error. In this case, you have to tune it, or you have to calibrate it. Okay, the error will occur if the instrument's results, the proper zero setting is not there. So you have to do the proper zero setting. Okay. Then another error is there, that is called gross error, will occur in the measurement results if the pointer deflects between two of the scaling points. So two scaling points are there, the pointer is in between. Okay, the pointer is situated in between two scaling points. Okay, there is it's another type of error. Okay, the most important error is parallax parallax error. Okay, so what happened in parallax error? So you have to see the pointer reading in vertical motion, means perpendicularly. When the pointer is there, you have to see the pointer perpendicular vision. Okay, if that pointer is not perpendicular vision, if you see some of the angle to that pointer, definitely you are not getting the exact thing. That is the visual visual displacement. You see some visual displacement, so exact reading will not come. So this type of error is called parallax error. Okay, that's why you have to see the parallel, or you have to see the perpendicular vision to the pointer when you are going to be reading. Otherwise that error will be occur. The measurement results if the pointer is not set in the vertical position. So you have to all the time take the reading very meticulously, and you have to keep in mind that your pointer should show the exact reading. Okay, so if it is not coming exact thing, so definitely some error will be there in the calculations. Okay, I hope all of you able to understand. If you have any doubt, any queries, any question, you can ask me, so we can discuss some of the portion.
Sir, the slide issue, please resolve it, sir, somehow, sir.
So that slide issue, that is every time it is not in my hand. What is your name? Please can you tell me your name?
Sir, Ashish, sir. Sir, Ashish.
Ashish Pradhan. Okay, that slide issue, Ashish, just try to understand that I am taking the class from my office. Okay, I use that institute internet. Okay, so if that problem has occurred from institute point of view, means some network issues if there. Okay, so definitely that is not in my hand. Okay, and I am discussing the entire thing. Okay, and if you have, I am also providing that lecture videos. Okay, means whatever videos I have, I will provide you, and after that I will provide that slide. Okay, so that is in my hand. Whatever things in my hand, that I can be resolved, but that any delay, lag, so that is in my not in my hand. So how can I resolve it? You tell me, you give me some suggestion on it.
So you can ask institute to do something in this.
I am not getting your voice. Please be louder.
So you can ask the institute to do something like increase bandwidth or something like that.
So that is not, it is not possible to all the time that I am talking to that institute. Okay, that is not possible. You write a mail to our HOD. Okay, that I am not getting that on, that slider lagging. So what can I do? I can talk to my HOD also. That I can talk. So institute means to whom I need to talk. Okay, and I have lot of class, you can understand better. It's not like that only measurement I am taking. I having some lab, I having some PG class. Okay, lot of jobs are there, so I have to do all those things. Also I am taking the classes. Okay, you have some lot of referencing, you have it. Okay, that I am going to be provide the video means audio. Okay, the audio means recorded audio, everything. Okay, and that I am providing. Slide I also been provided. So if there is some delay is there, so what can I do? That problem has faced by the other students also. Okay, so you can write a letter to HOD madam that that problem I am facing. Okay, so what can I do? Madam can take, if madam can also inform it to the Dean Academics, I think so, if they are resolved. I can also inform verbally to the madam also that I am getting that queries from the students, and that slide is not changing due to network connectivity. It may happen, but I can give my best effort, best thing for you, that I can provide you, which whatever in my hand I can provide you. Okay. Is there any other doubt?
Sir, I have some doubt in the laboratory experiment, sir.
Laboratory experiment, this is not the lab class. You asked me in the lab class.
Yes, sir. Tomorrow morning I will ask you, sir.
So this is not the lab class, no? This is a measurement class. Okay. So is there any kind of Is there any kind of portion need to be rediscussed? You please tell me. Anybody having any doubt? You please tell me. So we have some time, so we can rediscuss some of the portion. Okay, so nobody having any doubt on it. Okay, good. Okay, so